Hello and welcome to the AI Research Roundup. I'm your host, Alex. Today is May 3rd, 2025, and we're looking at an interesting ICLR conference paper titled Brain Bandit, a biologically grounded neural network for efficient control of exploration, published just over 3 months ago on January 22nd. Okay, so this paper introduces a biologically inspired model, the Brain Bandit network, designed to better handle exploration in uncertain settings, drawing inspiration from animal foraging behaviors. Okay, so looking at their first figure, we see the basic architecture for a 2D Brain Bandit network. It has these two nodes, representing actions, receiving inputs about value and uncertainty. They have mutual inhibition, which helps determine the probability of taking action 1 or action 2. The figure also shows the network's energy landscape and activity over time, illustrating how it dynamically switches between these choices, mimicking biological decision circuits. Building on the network dynamics, this next figure really dives into how BBN implements Bayesian posterior sampling with that tunable uncertainty bias. Panel A shows the action probability depends sigmoidally on input value differences. Then, panels B and C illustrate how the curve's slope and intercept vary with uncertainty, distinguishing between optimistic, neutral, and conservative modes. This highlights the network's flexible control over exploration based on uncertainty. Following that, Figure 3 digs into parameter dependence and multidimensional behavior. Panels A and B compare the theoretical and simulated probability of sampling the attractor state linked to the highest input uncertainty, showing how it depends on network parameters B and K. They align nicely. Panel C then shows that even as dimensionality increases, the probability of sampling states based on high uncertainty remains distinct, demonstrating the model's scalability and robust uncertainty handling. Alright, moving to the results in Figure 5, we see how Brain Bandit actually performs against established methods. Panels A and B show its probability of picking the optimal action in 2- and 3-armed bandit tasks over trials, consistently topping other algorithms like UCB and Thompson sampling. Then, Panel C shows cumulative regret in the 6-arms MDP task, where Brain Bandit again achieves lower regret, demonstrating really efficient exploration across different scenarios. Okay, digging a bit deeper into how Brain Bandit achieves that strong performance. Figure 4 compares its exploratory behavior directly with Thompson sampling and UCB in a 2-armed bandit scenario. Panel A shows the slope of the choice probability curve decreases with total uncertainty for most methods, but Panel B really highlights the difference, showing how the intercept, or bias, changes with relative uncertainty. This visualizes BBN's tunable, optimistic, neutral, or conservative approaches versus the fixed strategies of the others. Alright, so after comparing BBN to other algorithms, Figure 6 shifts focus to biological plausibility. Panels A and B compare the model's fitted slope and intercept, those parameters we saw earlier, directly against actual human behavioral data from bandit tasks. You can see a pretty good alignment there. Then, panels C and D show BBN replicating choice optimality and action switching patterns observed in mice, particularly around block transitions, further grounding the model in observed biological behavior. Okay, so beyond matching biological data, Figure 7 demonstrates how a BBN-enhanced RL agent performs in the 4-rooms task, a more complex grid world. Panel A just shows the layout. Panel B then plots the state coverage rate, basically how much of the environment is explored. You can see the UBE-BBN agent explores significantly faster and more thoroughly than other methods, like PSRL or UBE-UCB, highlighting its exploration efficiency in an actual RL setting. So, wrapping up, we saw how Brain Bandit really boosts exploration in complex tasks like 4-rooms. The key takeaway here is that BBN provides this biologically grounded way to handle exploration, combining Bayesian sampling with that flexible uncertainty bias. This approach significantly enhances RL agent efficiency, especially when deep exploration is needed. That's all for this AI Research Roundup. I'm Alex. Thanks for joining me.